This is GCSE Mathematics Practice Set 8 for the Edexcel High tier. Paper 2 is a calculator paper. 1 hour 30 minutes is the time limit. Let's get straight into it. Question 1 says, work out the difference between the largest share and the smallest share when 3,450 yen is divided into the ratios 2 to 6 to 7. We can find the number of parts in this ratio by adding these numbers up. So 2 plus 6 is 8, plus 7 is 15. So I would start by saying total parts equals 15, and then therefore each part will be the total divided by 15. So what we want to do here now is 3,450 divided by 15, and we want the difference between the largest and the smallest share. So we would do the largest share would be 1 part. This is essentially what 1 part of the ratio is worth. Multiply that by 7 to get the largest share, and then to get the difference we subtract the smallest share. So we would do 3,450 divided by 15 again, and then multiply that by 2. So that's the operation that I would put into my calculator. So 3,450 divided by 15 times 7, subtract, and I get an answer of 1,150. Okay, so that's my final answer there for 3 marks. Question 2 says, Gopal is paid £20,000 per month. Jamuna is paid £19,200 each month. Gopal and Jamuna are both given an increase in their monthly pay. After the increase, they are both paid the same amount each month. Gopal was given an increase of 8%. Work out the percentage increase that Jamuna was given. Okay, so if Gopal was given an increase of 8%, what we can use here is the multiplier to find out what he has, what his pay is now. So he was on £20,000 per month, and we multiply this by 1.08 to get an 8% increase. This is what we call the multiplier. It's essentially 1 plus this percentage as a decimal. So you should know this is 0.08 as a decimal. Put that into a calculator, you increase 20,000 by 8%, and this is 21,600. So that's the calculator strategy. Usually look for the multiplier if it's a calculator paper. So now what we want to do is work backwards to say, well, what have we increased 19,200 by to get to 21,600? In other words, we want to do the same operation, but we'll have a different multiplier here, and we want to end up with 21,600. So how would I find this thing in here? Well, I could divide 21,600 by 19,200 to get this unknown in here. Let's call that x. So we would do 21,600 divided by 19,200, and that will give us the percentage. So let's go ahead and put that into the calculator. 21,600 divided by 19,200. Well, this won't be the percentage, this will be the multiplier. So we have a multiplier of 1.125, and we need to subtract 1 to get the percentage. We would get 0.125, which translates to a percentage of 12.5%. So just to be really clear, we've done 1.125, take 1 equals 0.125, which is 12.5%. All right, plenty of ways to approach percentages questions. That's one method. Another way to do this would be to find the difference between these two numbers, 21,600 and 19,200, and use that difference and find that as a percentage of this amount. So a couple different strategies to do that question. Hopefully that one makes sense to you. Question 3 says, there are some people in a cinema. 3/5 of the people in the cinema are children. For the children in the cinema, the number of girls to the number of boys equals 2 to 7. There are 170 girls in the cinema. Work out the number of adults in the cinema. Alright, so they've given us the ratio of girls to boys, and they've also told us the number of girls. So what that's going to allow us to do is to work out the number of boys as well. So if there's 170 girls, in this ratio we have 2 parts girls. So that means each one part of this ratio would be half of 170. Right, so we could say 1 part is a half, which is 85, and then we can work out what 7 parts is worth. So we could say therefore the boys would be 85 times 7. 80 times 7 is 560, plus 35 is 595. So there are 595 boys, 170 girls. So then we know the total number of children in the cinema. So 595 plus 170, that's like 600 plus 165, 765. And then go back to the question again. It tells you that 3/5 of the people in the cinema are children. That means then that 2/5 are adults of the people in the cinema. So adults are 2/5 of the total. So we could write that, sorry, that should be an L there. So we could write that ratio of adults to children as 2 to 3. So we know the total parts is 5 and the proportions are 2 and 3, so that means the ratio is 2 to 3. Then using the fact that there are 765 children, we could again use the same approach. We could find what one part of this ratio is worth. So 765 divided by 3. If we put that into a calculator, we get 255, and then multiply it by 2 to get the number of adults in this ratio. So 255 times 2, and that gives us 510. And remember, that's what we were looking for, work out the number of adults in the cinema. So we've got our final answer of 510 there. And that was question 3 for 5 marks. I'll just point out it is important to recognize the connection between these fractions and the ratio of adults to children. So you're kind of converting proportions into a ratio, and that's important to understand for this question. But let's move on now. Question 4 says the diagram shows two cylinders, A and B. Cylinder A has height 1.6 meters and radius 0.56 meters. Part A says work out the curved surface area of cylinder A. Give your answer in meters squared correct to 3 significant figures. Okay, this is a little bit tricky because when you see surface area, you might be tempted to look for the total surface area, but it says curved surface area, so we're only looking for the tubed part of this, in other words, like the bit around the outside of the tube, not the circles on the ends. So the curved surface area is what we're looking for. And to work that out, you need to know that when you unroll a cylinder, this curved part becomes a rectangle. So what you're looking for here is the area of a rectangle, and you need to know how to find the length of that rectangle. Once you unroll it, the length is the circumference of the circles on the ends. The width they give you as the height of the cylinder. So to find that length of that rectangle that curved surface area would become, you need the circumference of this circle, and you know that the circumference of a circle is 2 pi r. So we can work out that length because they give us the radius. So the curved surface area is going to be the width, 1.6, multiplied by the circumference of that circle, which is going to be 2 pi times 0.56. And let's go ahead and put that into a calculator. So 1.6 multiplied by 2 pi multiplied by 0.56, and that gives us 5.6297. 5.6297, and it goes on. And we need to round it to 3 significant figures. So to 3 significant figures, this is the 4th significant figure. So therefore it's above 5. That 2 will round up to a 3. So this would round off to 5.63 meters squared. Also, always make sure that the units are already in meters. Sometimes they put them in centimeters, and you need to remember to convert them. But they were already in meters, so therefore our answer will be in meters squared. Part B says cylinder B is mathematically similar to cylinder A. The height of cylinder B is 0.6 meters. Work out the radius of cylinder B. Okay, so because they're similar, it will have a scale factor between the cylinders, and that scale factor will be consistent on all the lengths. So firstly, I can work out that scale factor because they give us the height of B. So the scale factor is going to be what I multiply 0.6 by to get 1.6, or in other words, 1.6 divided by 0.6. So let's write down scale factor, 1.6 divided by 0.6, and well, this is like 16 on 6. It could simplify to 8 on 3, or you could get a decimal for that. That would be fine as well. However, now we can work out the radius of B, because remember, this is what we're multiplying by to get this height over here. So multiply by 8 on 3. So to get from the radius, this radius, to the radius of B, we would want to divide by 8 on 3. In other words, multiply by 3 on 8. So to get the radius of B, we're going to multiply this radius by 3 on 8. Okay, so then we'll do 0.56 multiplied by 3 on 8, and let's put that into a calculator. We get 0.21. So the radius then of cylinder B is 0.21 meters. And that's question 4 for a total of 4 marks. Question 5 gives us a diagram, and it says M, N, and P are points on a circle center O. MON is a diameter of the circle. MP equals 3.5 centimeters. PN equals 9.7 centimeters. Angle MPN equals 90 degrees. Work out the circumference of the circle. Give your answer correct to 3 significant figures. So just as we talked about in the previous question, we know the circumference is 2 pi r. Another way of stating this is pi times d, the diameter. So the problem here is we need the radius, or the diameter. They give us a right-angled triangle, and we know how to work out the hypotenuse, or the longest side of a right-angled triangle, using Pythagoras' theorem. So hopefully you can see we're going to need to use Pythagoras' theorem to work out the diameter, and then we'll get the circumference. So let's say the diameter then is going to be the square root of those legs squared and added together. That's what the Pythagoras' theorem tells us. So 3.5 squared plus 9.7 squared. And let's put that straight into a calculator. So the square root of 3.5 plus 9.7 squared, and we get 10.3121, etc. 10.3121, and then plug that into the circumference formula multiplied by pi, and that should give us the circumference. So what we could do on our calculator is use the answer key. You should have an answer key somewhere on your calculator. It takes the previous answer and then multiply that by pi, and we get a circumference of 32.396, and it says round it off to 3 significant figures. So 9 would be the 4th significant figure, therefore that 3 needs to round up. So this would be 32.4 rounded off. So 32.4 centimeters for a final answer. That was question 5 for 4 marks. Question 6 says work out the value of x. Give your answer correct to 3 significant figures. Here x is the hypotenuse of this right angle triangle. For this you're going to need your trigonometric ratios. One way to remember these is this mnemonic, SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent ratio is opposite over adjacent. Hopefully you've seen that before. Which one are we going to need here? Which ratio? Well, we have the adjacent side to the angle, and we have the hypotenuse. So therefore, we're looking at the cosine ratio, adjacent and hypotenuse. That's going to allow us to find x. So firstly, we could say that the cosine of theta equals adjacent over hypotenuse. So therefore, cosine of 52 equals 12.6 divided by x. Now you need to know how to rearrange this. So you need to multiply by x, divide by cosine of 52, and you'll have x equal to 12.6 over the cosine of 52. And that's how we're finding that unknown. And now we need to plug that into a calculator. 12.6 divided by cosine of 52, rounded to 3 significant figures, this would be 20.5. That 6 means that 4 needs to round up to a 5. So approximately 20.5 centimeters, was it? Centimeters. Okay, that was question 6 for 3 marks. Question 7 says solve the simultaneous equations x plus y equals 15 and 7x take 5y equals 3. Show clear algebraic working. So you can either use elimination or substitution for simultaneous equations. I'm going to use elimination by multiplying this first equation by 5. So if I multiply this whole equation by 5, every term in this equation needs to be multiplied by 5. I would end up with 5x plus 5y equals 15 times 5, that's 75. So this is the same thing. This equation is still the same because if you multiply everything in an equation by the same amount, you still have the same equation. So this is still the same, and I'll show you why I've done that in a second. Next, we write the second equation underneath that, and now why I multiplied this by 5 is so that I have the coefficients of y to be the same. When you're using elimination, so this is the elimination method, you want the coefficients of one of the variables to be the same. And then what you can do is, if the signs are different, you add these equations together. Then we have plus 5y, subtract 5y. So think of this as like you're just adding two numbers, right? It's essentially what you're doing. It's the same thing. If I just added two numbers, you add the numbers in their place values. Same for this. I'm just adding the things in their columns. So 5x plus 7x is 12x. And then 5y plus negative 5y, that's 0. So I've eliminated that y variable. That's the point of this elimination method. So then 75 plus 3, that's 78. Then we have 12x equals 78. That allows us to say that x would be 78 divided by 12. How many times does 12 go into 78? 78 divided by 12, 6.5. Next, once you have a value for one variable, plug it in to one of the original equations. This looks like the easiest one to use. X plus y equals 15. I know x is 6.5 now, so then we'd have 6.5 plus y equals 15. So then y is going to be 15 take 6.5. 15 take 6 is 9, take half is 8.5. So my final answer there is x equal to 6.5 and y equal to 8.5. That was question 7 for 3 marks. Question 8 says Charlie bought a boat for £160,000. The value of the boat depreciates by 4% each year. Work out the value of the boat at the end of 3 years. Give your answer correct to the nearest pound. Okay, so for this you need the compound interest formula, which says the amount you end up with is equal to the principal multiplied by 1 take the rate to the power of the number of compounding periods, or I just usually use t for time, the amount of time that it is invested, usually in years. So if it's 3 years, that t would be 3. So anyways, that's the formula for compound interest. You can also use that for depreciation. You need to know what this word means here, depreciates. That means reduces. So the value of the boat goes down by 4% each year. So what we're actually saying then is, if we're going to use this compound interest formula, the rate is actually going to be subtracting. So I made a little mistake here. Usually this is a plus for compound interest. Usually it's 1 plus the rate. So when we're depreciating something, we do 1 take the rate. So let's plug the values in here. So the principal is 160,000. So the amount that it ends up being will be 160,000 multiplied by 1 take the rate, which is 4% as a decimal, that's 0.04. And the time that we're looking at is 3 years, so t is going to be 3. And then, well, this is going to be 160,000 times 0.96, 1 take 0.04 to the power of 3. And then we need to put that into a calculator to work out how much it has depreciated by. So 160,000 multiplied by 0.96 to the power of 3, and we get 141,557.76, and we need to give it to the nearest pound. So these would be the pence, and we need to round up to 8 pounds on the end there because we have a 76 pence, so that rounds up. Okay, so my final answer there is going to be 141,558 for 3 marks. Part B says Jenny gets a salary increase of 5%. Her salary after the increase is 252,000. Work out Jenny's salary before the increase. So the strategy here for a calculator paper, I would suggest that the best or the most straightforward method is to say, well, if I've had a 5% increase, that means I'm now getting 105% of what I was originally earning. So this 105% equals what I am earning now, 252,000. Sorry, what Jenny is earning now. And then if I want the original salary, we're saying that the original salary multiplied by 1.05, using that idea of that multiplier, is going to be 252,000. So that original salary is 252,000 divided by 1.05, and that's going to give you the original earnings. Put that into a calculator, 252,000 divided by 1.05, 240,000, nice even number there. Okay, so that idea of that multiplier for percentage questions in calculator papers, I think, is important. That was question 8 for a total of 6 marks. Question 9 says diagram shows a right angled triangle. Here we have the diagram with an angle 72 degrees and one leg 12.8 centimeters. 5 of these triangles are put together to make a shape. Here's the shape. Calculate the perimeter of the shape. Give your answer correct to 3 significant figures. Okay, so I think that's a bit of a typo there. Sorry about that. But let's have a look at this shape then. We have this leg here. We actually know that length already. How many of those lengths do we have? So by the way, it's asking for the perimeter. That's going to be all of the lengths around the outside. So we have this leg 1, 2, 3, 4, 5 times, and then the only other length we need to work out then is this one in here. Well, that's going to be the hypotenuse. Subtract the smaller length here, this little leg, right? To get that length, we need to do the hypotenuse, take that smaller leg. So we actually need to work out this side. Let's call that A, and we need to work out the hypotenuse. Let's call that H. So I guess it's really up to you how you do this. You could use the tan ratio to work out A, or the sine ratio to work out H. So for example, we know that the sine of an angle in a right angle triangle is the opposite side over the hypotenuse. In this case, we have the opposite side of this angle here, and we are looking for the hypotenuse. So because we have that angle on that side, we can work out the hypotenuse using the sine ratio. So let's go ahead and do that first. So we would say that sine of 72 equals 12.8 over the hypotenuse, which we're calling H. So rearranging this, then we would say H is equal to 12.8 divided by the sine of 72. So let's see what we get for that. 12.8 divided by the sine of 72. We get approximately 13.46. Let's just round that off for now. 13.46. So that's approximately. And then we can use that side then to work out the shorter side using Pythagoras, or again you could use tangent. Either way, it's up to you. So the shorter leg we called A is equal to the square root of the hypotenuse squared, subtract the other leg squared, 12.8 squared. Let's put that in, and we get 4.1589. Let's just round that off to 4.16 for now. 4.16. Again, that's approximately. Okay, so now we have the shorter leg in the hypotenuse. Again, we said this side would be h take a. So then let's work that out. So h take a, 13.46 take 4.16. And it would be good actually if I could get an exact number. So I might put in that calculation again. So 9.2997. 9.2997. Okay, so now I have that length. I have 5 lots of that length and 5 lots of the longer leg. So the perimeter then I can say will be 5 times 12.8 plus 5 times 9.2997. And let's see what we get for that. So 5 times 12.8 plus 5 times our previous answer, and we get 110.4987. It says give your answer correct to 3 significant figures. Well, that 4 is the 4th significant figure. It's less than 5, so we would leave that as 110. So I'm just going to round that off straight away. This would be 110 centimeters rounded off to 3 significant figures. 5-mark question there. Quite a bit of work and understanding. You need to know the trigonometric ratios, you need to know Pythagoras, and you also need to know how to find the perimeter of this kind of complex shape. So there you go, question 9 for 5 marks. Question 10 says a solid metal sphere has radius 1.5 centimeters. The mass of the sphere is 109.6 grams. Work out the density of the sphere. Give your answer correct to 3 significant figures. Okay, for this, you actually need the formula for the volume of a sphere, and they don't give it to you in this paper, but it is not something you need to memorize. They will give this formula to you in the actual exams. So the formula for the volume of a sphere is 4/3 pi r cubed. Again, not something you need to memorize. We also need to know the relationship between density, mass, and volume, and you can remember this using this triangle. So at the top of this triangle is mass, and then we have density, volume. This tells you the relationship between these three. So for example, if we're looking for density, you can see the relationship here. D is going to be m over v. So we can say the density is the mass divided by the volume. So they've given us the mass. We're going to have to work out the volume using the volume of a sphere. So V equals 4 on 3 times pi times the radius cubed. So we would have 1.5 cubed. So let's work that out first. 4 on 3 times pi times 1.5 cubed, 14.137, etc. And then we can work out the density. Making sure to check the units, so they're looking for grams per centimeters cubed. Luckily the mass is already in grams and the volume will already be in centimeters cubed, so we don't need to worry about the units there. We just need to do 109.6 divided by the volume, and that should give us the density. So let's put that into the calculator. 109.6 divided by our previous answer, 7.7526, rounded to 3 significant figures. Look at that 4th significant figure. Is it less than 5? Yes, it is. So we would leave that as 7.75. Okay, so 7.75 to 3 significant figures there. Question 10 for 3 marks. Question 11 says, expand and simplify 2x take 1 multiplied by x plus 3 multiplied by x take 5. My approach to these triple brackets questions is to firstly expand out one set of double brackets. So you could look at these brackets first and then do the second set of brackets afterwards. So firstly use FOIL, so 2x plus x, the first terms in those brackets, 2x plus x is 2x squared, outers plus 6x, inners, -1 times x is -x, and then last, -1 times 3 is -3. So that's the first set of brackets expanded. And then actually let's simplify this first. So this would be 2x squared plus 5x take 3, 6x take x. And then what you want to do is multiply everything in this first bracket or this first quadratic by the second expression. So 2x squared times x is 2x cubed. 2x squared times negative 5 is negative 10x squared. Then 5x times x is 5x squared. Then 5x times negative 5 is negative 25x. And then negative 3 times x, negative 3x. And negative 3 times negative 5 is positive 15. And then we can go ahead and simplify this. So this would be 2x cubed. There's no other x cubed terms. So what we're doing here is collecting like terms. So the x squared terms, we have a negative 10 plus 5. That would be negative 5x squared. Negative 25x take 3x. That's negative 28x. And then we have that constant term on the end. So final answer there would be all of that. Okay, and that was question 11 for a total of 3 marks. Question 12 says the students in class A and in class B take the same examination. There are 28 students in class A and 32 students in class B. The mean score for all the students in both classes is 72.6. The mean score for the students in class A is 75. Work out the mean score for the students in class B. Alright, so what is a mean? Firstly, a mean is the total, in this case it would be the total score for all students divided by the number of students. So then we can use that formula for the whole class because they give us the mean for all of the students all together, and we have 28 plus 32, so 60 students altogether. So we could say the class A and class B scores, they must be the mean of 72.6 multiplied by the number of students, which is 60. So I've just rearranged that to find the total score. So the mean times the number of students will give you the total scores for both classes. And we can also do that for the class A scores just by themselves because they give us the mean for class A. That would be 75 multiplied by 28, the number of students in class A. And then therefore class B, the scores for class B is going to be the total score for both classes subtract the total score for class A. So for class B scores, I'm going to take this, subtract 75 times 28, and then I'll have the scores for class B. Okay, so let's put that into a calculator and we get 2,256. So now I have the total scores for class B. I can divide by the number of students to get the mean score. So the mean for B is going to be the total divided by 32. And put that into a calculator, divide by 32, and we get 70.5. So essentially you need to know how to calculate the mean, and you need to know how to manipulate that formula to get the total scores and then kind of work backwards to get the mean. Okay, that was question part A for 4 marks. Part B says the lowest score in class A is 39. The range of scores for class A is 57. The lowest score in class B is 33. The range of scores for class B is 60. Find the range of scores for all the students in the class. So class A is 39, and the range means the difference between the highest and the lowest score. So we need to work out the highest score for A. That would be 39 plus 57, and 39 plus 57 is like 40 plus 56 is 96, and then the highest for B is going to be the lowest score plus the range, so that's 93. So then we can work out the range of both classes. It's going to be the highest score, in this case it's 96, higher than 93. Take the lowest, which was 33. That will give us the range for both. 96 take 33 is 63. So final answer there, 63 for 3 marks. Question 12 is a total of 7 marks. Question 13 says E equals 8.31, correct to 2 decimal places, and F equals 0.65, correct to 2 decimal places. Work out the lower bound for the value of E take F. Show you're working clearly. So firstly, what you want to do here is to write the error intervals for each of these constants. So if you say that it's correct to 2 decimal places, what you want to do is add on an extra decimal place and see what it rounds to. So for example, 8.305 would round up to 8.31. And so then we say that E is greater than or equal to 8.305, and it's less than what would round down to 8.31? That's 8.315. So you really need to know or be good at rounding off to, say, a certain number of decimal places. So one thing that might help you is to write out a number line. And if you're rounding to 2 decimal places, what you want this number line to be is to 3 decimal places. So you might want to do, write out 8.310, which is essentially this number to 3 decimal places. You would add a 0 on there. So think of that as 310, kind of, and then go down in 5 and up in 5. So what's 310 take 5? That's 305. And then add 5 on, so this would be 8.315. And so that's the error interval. So when it says correct to 2 decimal places, you can also, once you write it like this, you can kind of think about this number as 310, and then you're rounding off to the nearest 10. Okay, so you can change that to rounding off to the nearest 10 if you like, if you find that easier. Same for the next one. So if you want to use this strategy for F now, draw out your number line, and remember we're thinking about this as rounding to 2 decimal places, so you need to write this to 3 decimal places. This would be 0.650, or 650 after the decimal point. What's 650 take 5? That's 645, so 0.645. And then what's 650 plus 5? That's 655, or 0.655. So now your error interval for F is going to be greater than or equals to 0.645 and less than 0.655. And it's always the case when you're writing error intervals, it's greater than or equals to, because that rounds up. This one doesn't round down, but it's everything less than that rounds down to F. Okay, so that's one strategy you can use to help you with lower and upper bounds. And now we're looking for the lower bound of the value of E take F. Well, what's going to give you the smallest amount for E take F? It's going to be if E is the minimum value for E, so the lower bound for E, and F is the upper bound. That's going to give you the smallest difference between them. So what we want to do for the lower bound of E take F is going to be 8.305 subtract 0.655, the upper bound of F. And that's going to give us the lower bound. Let's use a calculator to find that difference, and we get 7.65. Okay, there we go. That is question 13 for 2 marks. Question 14 says the diagram shows a triangular prism. AF equals 10 centimeters, AB equals 24 centimeters, and BC equals 8 centimeters. Angle FAB equals ADC equals angle BCD equals 90 degrees. So let's just look for those quickly. So these lengths are drawn in already. Angle FAB is this one here. They've drawn in that 90 degrees. Angle ADC is up here. So they've already drawn in those 90 degree angles. Work out the size of the angle between the line BE and the plane ABCD. Give your answer correct to 1 decimal place. So for this, you really need to think in 3 dimensions. So this is a 3-dimensional shape. That's what a prism is. Also, a prism it has the same cross section all the way through. So this right angle triangle at the end here, that's going to be the same all the way through. So what we can rely on here is the fact that this edge, or this side over here, is going to meet this edge or this plane at 90 degrees all the way across, and that length is going to be the same all the way across. Also, these lines AD and BC are going to be parallel, same for the other sides. That's why they're all meeting at 90 degrees. The first thing I'm going to start off with is to look for the length BD here. So going from D to B across here, because what I'm looking for is this angle in here between this length BE and the plane, And what you want to do is to create a triangle to find that angle. So the triangle I'm going to create here is this EDB triangle, and this is going to be a right angle triangle because this side here meets this plane at 90 degrees. We already know that. So I've created a right angle triangle, BDE, and I know this length over here, DE. Because this is a prism, it must be the same as AF, so this is going to be 10 centimeters, DE. And what I want to do is to find the length of BD using Pythagoras Theorem, because I know this length BC is 8 centimeters, I know this length DC would be 24 centimeters, so I have a right angle triangle in here where BD is the hypotenuse. So I'm going to use Pythagoras Theorem to find BD, so this would be the square root of 24 squared plus 8 squared, and put that into a calculator, so square root, and I get 25.298, etc. 25.298, and so that's the length of BD. I have the other leg, so I have two lengths of that triangle, and I'm looking for that angle in there. Now we can use a trigonometric ratio to find that angle. So which trigonometric ratio should I use if I have two legs of a right angle triangle? That's the tan ratio. I know that tan of an angle equals the opposite side over the adjacent side. In this case, I'm looking for theta, so I'd say tan theta equals opposite side, which is 10 dE. So 10 over the adjacent side, which was BD, which we found up here, 25.298. And then to find theta, I want to take the inverse tangent of those things. So then I want to put that into a calculator, and I get 21.568, and it says give your answer correct to one decimal place. So look at the second decimal place. If it's above 5, I need to round up, so I need to add 1 to that 5. So this is going to be approximately 21.6 degrees. So final answer there, 21.6 degrees, for a total of 3 marks for question 14. Question 15 says complete the table of values for y equals x cubed take 2x squared take 3x plus 4. For this, I'd probably get some rough note papers somewhere and actually work these out rather than trying to do them in my head. So, or you can just write them in the margin here somewhere, but find somewhere to do a bit of working out here. So for the first one, I'm substituting -2 into this equation here. So y is going to equal -2 cubed take 2 times -2 squared is going to be 4. -3 times -2, that's +6 plus 4. So then I have -2 cubed, that's -8, take 8 plus 10. So -16 plus 10, that would be -6. So the y value there, -6. Next, as I said, just do this on rough note paper because you don't get marks for any of this working out, but it does help so you don't make mistakes. Next one, I've got -1 cubed take 2 times -1 squared, that's just 1, so I just have -2 there, plus 3. -3 times -1 is +3 plus 4. -1 cubed is -1, take 2 plus 7, so that's -3 plus 7, that would be 4, +4. Next, plug 1 in. Maybe for some of them you don't need to do working out. So if I put 1 in here, actually I'm still going to write it down. So 1 cubed is 1, 1 squared is 1, so that would just be -2, take 3 plus 4. In this case, I've got -1, take 3 is -4 plus 4, so final answer there would be 0. Next one, 2 cubed is 8, take 2 squared is 4, so this would be -8. -3 times 2 is 6, so this would be negative, and then add 4 on the end. These 8s would cancel, I'd have -6 plus 4, final answer there would be -2, and the final one is 3, so plug 3 in. 3 cubed is 27, 3 squared is 9, times 2 is -18, 3 times 3 is 9, so -9 plus 4. Then I have 27 take 18 is 9, take 9, they would all cancel out, then I'd just be left with positive 4 there on the end. Okay, so that's your table of values for 2 marks. Part B fairly predictably asks you to plot this graph. So it says on the grid, draw the graph of y equals x cubed take 2x squared take 3x plus 4 for the values of x from -2 to 3. So that's just this table of values. So what we want to do is take these points and plot them. So -2, -6, -2, -6 is down here. Next one, -1, 4, -1, 4. Now you should know the general shape of a cubic. It's kind of like this. So we should end up with something like this once we've plotted all the points. If you don't, double check you're working out. So -0.54, 0.875. It's a bit more tricky. So -0.5 is there. 4.875. Well, that would be 5 here. So this would be 0.6, 0.8. I guess it would just almost be at 5, somewhere there. Okay, I guess it doesn't need to be exact, but you want it fairly close. 1, 0, 1 on the x-axis, 0 on the y-axis. 1.5, -1.625. 1.5, -1.6 would be here. So, oops, that's a bit far down. Probably almost on 1.6, basically. Okay, about there. Then 2, -2, that's here. Then 3, 4, 3, +4. Okay, so we've got that shape. You can see it's going to go up and then down and up again, so that's good. Happy with that. Now you need to sketch it. I would do this with a pencil and try to get it so it looks pretty nice and smooth. Now I'm going to struggle here. Now if you have long gaps like this, it might not hurt to actually rule it in, and if it looks too straight you might want to try to sketch it, or possibly rule it in and then sketch over it to get a nice sketch or a nice curve rather than it's looking too straight, because if you join these up with a ruler so they're all straight, you won't get the marks. That's why it says, well, this is a curve, so a cubic is a curve, so if you're joining them up with a ruler, you're not going to get a curve, you're going to get a series of straight lines, and you don't get the marks. So you need to sketch these in as best you can with a pencil. I think it's generally okay if it has a few sketch marks like that. If you want to neaten that up afterwards and kind of go over it a bit heavier and then rub out those sketch marks, that'll be fine. But make sure you're drawing the curve rather than ruling the lines. Okay, that should get you your 2 marks. As long as you plot all the points correctly and draw that curve in, that should be good for 2 marks. Part C says, by drawing a suitable straight line on the grid, find the estimates for the solutions of the equation x cubed take 2x squared take x plus 1 equals 0. Give your solutions correct to 1 decimal place. So firstly, we are looking for a connection between this or this equation and this one here. They're not just giving you a random cubic. You need to find how to convert this cubic into this one. So firstly, let's write down this one down below so we can compare them a bit easier. So we have the sketch of the cubic x cubed take 2x squared take 3x plus 4. That's what we started with. So now let's compare these. How could I turn this into this equation here? What could I add or take away? So what I would do is write this down here. So x cubed take 2x squared take 3x. And once I get to the x, because you notice that this first part is the same, right? This x cubed take 2x squared, that's the same. We're just worrying about these last 2 terms. So negative x and negative 3x. Well, if I split this up, actually, so rather than writing negative 3x, what I want is to write negative x, and then how could I get negative 3x? Well, I'd have to take a negative 2x. So I've split that up into negative x and negative 2x. And I can do the same for 4. So I've got a positive 1, and then I'd also have a positive 3. So 4 I can split up into 1 plus 1 plus 3. And now to make these two things equivalent, so I started with x cubed take 2x squared take x plus 1 equals 0, whatever I introduce on the left hand side, I need to introduce on the right hand side as well to keep it balanced. So I started with this, I introduced a negative 2x and a plus 3, so I need to bring those on the right hand side as well. So actually I'll write the 0 in as well. So I've got 0 on the right hand side, take 2x plus 3. So this is about comparing the cubic you're given with the equation in this part of the question and seeing what you need to add or subtract to make those, to connect those two things. Okay, so now on the left hand side, I can rewrite this again, simplify it down to x cubed take 2x squared take 3x plus 4, and now on the right hand side I have negative 2x plus 3. So what does that tell you? Well, that tells you this cubic or this graph here that we've already sketched equals negative 2x plus 3, which is a straight line graph. This is a straight line graph. We have it in the form y equals mx plus c. You should know that that is the form of a straight line graph, and you should also know how to sketch this on the graph. So negative 2 is the gradient and 3 is the y-intercept. So we can sketch that on our graph, and I might use a different color for that. So negative 3 again is the y-intercept, so put that point in. So we need to go down 2. So if we're going down 2 on the y-axis, we would go down to negative 1 and then across 1, and that would be all the way across like 2 of these kind of square things. So just be careful with the scale there. So that would be the next point, and then go down 2 again and across 1 just to make sure you're getting a nice straight line, and then sketch it in. So actually I might do one more because just to make it a bit easier. Alright, let's draw that line in, and that is the line of y equals negative 2x plus 3. And so now remember what the question is asking. We're looking for the solutions to this equation here, which are equivalent to this one here. That's the whole point. If we're solving this, we're also solving this one here. These two equations are equivalent because we kept it balanced, and so the solutions to this equation is where this cubic intercepts with this straight line. So wherever this straight line intercepts with this graph here, that will be a solution to this equation. So now we need to find the x coordinates, and this does get a bit tricky because you've obviously sketched in this cubic. So it is an estimate, it's not an exact answer, but they do give you a range of answers in the mark scheme. So this first one, I would say that meets about negative 0.9, negative 0.8. Possibly I could have done that sketch a bit more accurate. I'm going to say negative 0.8. So again, this is a good time to assess your sketch and say, okay, if I did it perfectly, maybe it would be a bit different. This one I'm going to say is at 0.5, and this one here I would say is about here on the x-axis at 2.3. Okay, so they are my x values for where the line crosses this cubic. So the solutions then are going to be negative, different color, are going to be negative 0.8, 0.5, and 2.3. And remember, you just need the x values because you're looking for the solutions to this. The only unknown there is the x. Okay, so that was 4 marks because these are quite tricky where you need to make that connection between the cubic and the equation they give you. Okay, that was question 15 for a total of 8 marks. Question 16 says simplify fully 256x to the power 20 over y to the power 8, all to the power negative a quarter. What I would probably do first is to introduce this power outside the brackets, inside the brackets. So what you want to do then is to multiply the exponent of everything inside the brackets by negative a quarter. What that means is, well, let's rewrite this again. This would be 256 to the power of negative a quarter multiplied by x to the power of 20 times a quarter is, well, 20 divided by 4. This would be negative 5. And then this is all over y to the power 8 times a quarter. 8 times a quarter is like 8 divided by 4. So this would be y to the power of negative 2. Okay, when you have negative exponents, that's like saying 1 over that thing. So in the numerator here, we would have 1 over all of this. So 1 over 256 to the power of a quarter. When you have something to the power of a quarter, that's the fourth root of that number. So this is going to be the fourth root of 256. And then this is multiplied by x to the power of 5. So I had 1 over x to the power of 5. So it's 1 over all of that. And then in the denominator, I have 1 over x squared. Now, if you want to simplify this, this is like when you have a fraction divided by another fraction. What you do with those is you say this equals the numerator, the fraction in the numerator multiplied by the fraction in the denominator flipped around. So we can write this now as y squared all over this denominator here. Let's firstly evaluate this fourth root of 256. What times itself 4 times equals 256? Well, you may know your powers of 2, or you may know your square numbers as well. So you may know, for example, that 16 squared equals 256, and then you would know that this is 4 times 4 times 4 times 4. Anyways, make sure you know how to do that on a calculator, but the fourth root of 256 is 4. So then this denominator becomes 4 times x to the power of 5. And that's about as simple as you can make this expression. So my final answer there is going to be y squared over 4x to the power of 5. That was question 16 for 2 marks. Question 17 says the histogram shows information about the birth weights of some babies. 6 of these babies had a birth weight less than 2.5 kilograms or greater than 4 kilograms. Work out the number of babies who had a birth weight between 2.5 kilograms and 4 kilograms. Okay, so 6 babies are less than 2.5, so I guess that's that bar in here. That would be 2.5 here. And greater than 4 kilograms, so that would be this bar in here. So the problem is, for this one, you need to work out the scale on the axis for the frequency density. So we're looking for the scale here. So the question really is, what is the scale? So we can use this information, 6 babies, less than 2.5, greater than 4, to help us work that out. So for example, I could say that this area, so if I labeled these areas, let's call this one A, and this one, let's call this area in here B. Those two areas added together equals 6. That's what you get when you find the area of a histogram. You get the total frequency. So those areas added together equals 6. How do I work out the area of A? Well, the length or the width I know is a half. So the area of A is 0.5 multiplied by how many of these little ticks here? I've got 1, 2, 3, 4. So going up to 4 on the frequency density axis, I would have 4 times these ticks. Let's just call that unknown x. So 4 times x. That will give me the area A. Plus the area B. The width for that bar is 1. I don't really need to write down that 1. But the number of ticks on the y-axis or the vertical axis is just 1. It's gone up by 1. So this would be 1 times 1. In other words, just x, that unknown. And this equals 6. That's the equation you need to come up with in order to find the scale for the vertical axis. Once you've got that simplified, so half of 4x is 2x plus x equals 6. And then 3x equals 6, therefore x equals 2. What was that x again? That was the scale over here. So each one of these little ticks or intervals is 2, a frequency density of 2. Therefore, let's do these major grid lines here. If I was going up by 2, 2, 4, 6, 8, 10, this would be 10, this would be 20, 30, 40, etc. Okay, so now we have the scale. We can work out the number of babies between 2.5 and 4 by working out the area of each bar. So firstly, this area, this is going to be, 8 times a half. So actually, let's just write that down. We're going to have the width a half times 8 plus the area of the third bar. Well, that's going to be 0.4. The width is 0.4 there, multiplied by the height, which is 40, plus the width for the fourth bar is 0.2, multiplied by the height, which is 50. The fifth bar, the width is 4.4 again, multiplied by the height, which is 30, and the last bar, we're not looking for that. We're just looking between 2.5 and 4. So we've got the area now. We just need to work this out. Half of 8 is 4. 0.4 times 40, that's like 40 divided by 10, which is 4 times 4, which is 16. A fifth of 50 is 10. 0.2 is the same as a fifth. And 2/5 of 30 is 30 divided by 5 is 6 times 2, which is 12. Okay, or you can just put that straight into a calculator. That would be perfectly fine as well. And then you've got 20 plus 22, that's going to be 42. Okay, so the total number of babies between 2.5 and 4 kilograms will be 42. That was question 17 for 3 marks. Question 18 gives us this shape, and it says the diagram shows a hexagon ABCDEF. BC is parallel to ED. Work out the size of the obtuse angle DEF. Now, which is the obtuse angle? Remember, an obtuse angle is between 90 and 180 degrees. So if it says angle DEF, if they didn't say obtuse, it could either be this one or this one in here. Now, because they say obtuse, we know it must be this one over here. This angle out here would be a reflex angle. So we're looking for this angle in here, DEF. And what I'm thinking is that I want to find this reflex angle DEF in order to find the obtuse angle. To find the reflex angle here, I want to find this angle in here, and I can use the fact that these are parallel lines. So if I just extended this a little bit, and this one as well, you'll notice something. If you know your rules of parallel lines, you'll know that these two angles here are co-interior, meaning they need to add up to 180. So 180 take 42, that's 138. So therefore we know that angle EDC equals 138 degrees. And it doesn't say give reasoning for all of your steps, so we don't need to explain how we got that 138. You can just draw it in your diagram to help you get to your final answer. Now, to find this reflex angle DEF in here, I'm going to want to find the interior angles of a hexagon. So to do that, I want to use the angles in a polygon formula, angles in a polygon, and that looks like this. This is n take 2 times 180. I have a video on this if you're wondering how to use this formula or where it comes from. So to work out the total angles in this hexagon, I need to substitute the number of sides, which is 6. 6 take 2 is 4, so I'd have 4 times 180. 4 times 180 is 720. So in that case, n is the number of sides. Okay, so that's the total of the angles in this hexagon. I have 5 of the angles. That means I can work out the remaining angle by subtracting all of these from 720. So I would say, therefore, that reflex angle DEF is going to be 720, subtract all of these ones added up. So 50 plus 96 plus 144 plus 42 plus 138. Add these all up, take them from 720, I'd end up with that reflex angle. So let's go ahead and do that, and I get 250. So that reflex angle in there is 250. Therefore, hopefully you can see straight away how to work out the obtuse angle DEF, because you know that angles around a point add up to 360. Therefore, the obtuse angle is going to be 360 take 250. Okay, so therefore, the obtuse angle DEF is going to be 360 take 250, and this is 110. So final answer there, 110 degrees. For a fairly generous 5 marks, I would say, for question 18. Okay, on to question 19. Question 19 says, a triangle has sides of length 8 centimeters, 10 centimeters, and 14 centimeters. Work out the sides of the largest angle of the triangle. Give your answer correct to 1 decimal place. So you need to know something about the largest angle in a triangle here. So firstly, let's do a quick sketch. We have the side lengths. This is not going to be at all to scale, but this is going to be the shortest side. This will be the next shortest. This will be the longest. In a triangle, the largest angle is always opposite the longest side, which makes sense, doesn't it, right? If you have a longer side, these two lengths are going to be wider apart, meaning this angle in here is going to be the largest. So this is the angle we're looking for. Let's call this angle A, and let's call this side A. So side A is 14, opposite angle A, and hopefully you know which rule you need to use here. There's only one law really that is going to help you. When you're given 3 side lengths and you're looking for an angle, you want to use the law of cosines, and that looks like this. So typically it's written as a squared equals b squared plus c squared, take 2bc cosine a. Usually you're given 2 sides an angle, you look for the other side, but you can also rearrange this. This is fairly common as well. You can rearrange this so it says cosine a equals b squared plus c squared, take a squared all over 2bc. This is a common rearrangement of the typical cosine rule. Once you've got it in this form, you can see that, well, if you have 3 sides, A, B, and C, you can work out angle A. So let's go ahead and plug these sides in, and it's important that the angle A is opposite the side A. So that's really the key to getting this correct. As long as you input the angles and side lengths in the correct places, you'll get it correct. So cosine A is going to equal b squared. Let's say b is 8 squared plus c squared is 10, and b and c doesn't really matter which way you get those around, but a is important. A is 14 squared all over 2 times 8 times 10, and let's go ahead and plug that in to a calculator. We've got on the top line 8 squared plus 10 squared, take 14 squared, and that's divided by 160, and I get negative 0.2. So that was cosine of A, and we're looking for that angle, so we need to do the inverse cosine of negative 0.2. Let's put that in now. Inverse cosine of our previous answer, and we get an answer of 101.536, and it says give your answer correct to 1 decimal place. So if I round this off, look at the second decimal place, it's a 3, so therefore we leave it as a 5. The first decimal place stays as it is. So this is going to be approximately 101.5 degrees. 101.5 degrees for my final answer there. So question 19, 3 marks. On to question 20. Question 20 says a frustum is made by removing a small cone from a large cone. The cones are mathematically similar. The large cone has base, radius r centimeters and height h centimeters. Given that the volume of the frustum to the volume of the large cone is 98 to 125, find an expression in terms of h for the height of the frustum. Alright, now they tell you the cones are mathematically similar, not the frustum and the large cone. That's important because you need to use this equation or this ratio down here and change it slightly so that you have the relationship between this small cone here, and the large cone. So that's the key to this really. So how can you find the relationship if you're given the volume of the frustum to the volume of the large cone? How can you find a relationship between this small cone and the large cone? As though instead of chopping off the frustum, you actually chopped off the smaller cone. That's kind of what you're pretending to do here. So then we've got a different height. Maybe we could call that HS for the smaller cone, and this might be HB for the, or HL for the larger cone. We need to find a relationship between those. Okay, so firstly, we've got this ratio. So what would then be the volume of the small cone to the volume of the large cone? What would that ratio be? Well, let's go back to the diagram again and look at this carefully. This is essentially saying that the volume of the frustum is 98, the volume of the large cone is 125, so then what is the volume of the smaller cone here? That would be the difference between those, 125 take 98. That is 27, so difference between 125 and 98 is 27. Therefore, this ratio is going to be 27 on 125. And just to be really clear, the way I got this 27 was I did 125 take 98. That's essentially the volume of the smaller cone, or the scale factor, or the ratio, the ratio between the small cone and the larger cone. Okay, once you get that point, I think that's probably the trickiest step, but anyways, once you get to that point, because they are similar, because the cones are similar, we can say that the height, the ratio of the heights, so the height of the small cone to the height of the large cone, that is the cube root of the ratio of the volume. So that's an important thing you need to know about similar three-dimensional shapes, is that the heights, the ratio of the heights, sorry, the ratio of the volumes, let's say it this way. So if we had one shape and the second shape, the ratio of the volumes is the cubed root of the ratio of the cube of the ratio of the heights. Okay, and you can reverse that to say the ratio of the heights is the cube root of the ratio of the volumes. So we want the cube root of 27 on 125. Luckily, these are two cubic numbers, so it makes it fairly easy. Cube root of 27 is 3. The cube root of 125 is 5. So now we know the ratio of the heights of the small cone to the large cone. So now you can think of this as like an equation. And remember, the height of the large cone is just h. They've labeled that h. So we can say the height of the small cone would be 3/5 multiplied by the height of the large cone, or 3/5 times h, right? So I just take that denominator, multiply it on the right hand side, and I end up with this equation here. 3/5 times h is the height of the small cone. And then remember what we're looking for. We're finding an expression in terms of h for the height of the frustum. Well, the height of the frustum would be h take this height here. And we've just found an expression for the height of the small cone. We're saying now this is 3/5 h. Okay, so what's h take 3/5 h? That's 2/5 h. Okay, so then, therefore, the height of the frustum, so let's just write this down so we're showing all of our working out. The height of the frustum equals h take 3/5 h, which is 2/5 h. So 1 take 3/5 essentially. You're left with 2/5. So an expression in terms of h, 2/5 h centimeters, because all of these were in centimeters. Okay, that was question 20 for 4 marks. Fairly difficult first step, I think, for that one. But if you know about your similar three-dimensional shapes, the rest, I think, should be okay. And that's the end of the paper. How did you go with that one? I hope you found it okay. Let me know in the comments how you went. I hope you found that useful. Please leave a like if you did find it useful. I really appreciate the likes. It tells me that you appreciate what I'm doing and that you want me to do more. So if you do want me to continue with these, please leave a like. And also, if you want to see more content, subscribe. And if you're looking for paper 3, there should be a link to the playlist in the description. Other than that, I'll see you in the next one. Bye for now.